So in the previous video, we talked about how to compare sizes of cations and anions with respect to their parent neutral atom. We can also say something about ions that are in the same isoelectronic series, which is what we're going to do in this next problem. But first, we need to, before we answer this question about which ion in that list of sulfide ion, potassium, phosphide, and calcium ions, which one is the smallest to largest, we need to define what exactly does isoelectronic mean. Isoelectronic means that species has the same number of electrons but different numbers of protons. If you remember way back in the first unit, we talked about isotopes. Isotopes have the same number of protons but different number of neutrons. This term, isoelectric, means same number of electrons but different numbers of protons. And so to prove to you that these three ions are indeed isoelectronic or isoelectric, let's go ahead and let's look at their electron configurations, and we'll just do the abbreviated version. So if I was to do a regular sulfur atom, that would be my abbreviated electron configuration. Sulfide ion, that sulfur is in group 6. It likes to have a -2 charge. So that means I need to add 2 electrons to my highest principal quantum number orbital. So my electron configuration for the sulfide ion is this. And so if you add up the total number of electrons, including the cores of neon, which is 10, plus 2 plus 6, you have a total number of 18 electrons. We should go ahead and do something similar with potassium. So there's potassium as a neutral atom. Potassium's in group 1. Group 1 atoms love to lose electrons, and specifically lose 1 electron to be at +1 charge. So the electron configuration for that ion is going to be the same as argon, and argon has a total of 18 electrons. So far we're looking good. These two are indeed isoelectric or isoelectronic. Phosphorus, because we have been asked for the phosphide ion. This is a electron configuration for neutral atom of phosphorus. Phosphorus is in group 5. Phosphorus, along with nitrogen, likes to be a -3. So when we add 3 electrons, this is what our electron configuration it becomes, which is the same, exact same as sulfur, -2, so 18 electrons. And then we can do a similar exercise with calcium and the calcium-2 ion to confirm that, oh yes, all of these ions do indeed have a total of 18 electrons. So they are in the same isoelectronic series. Okay, so now that we've determined that, how do we answer the question which one is bigger and which one is smaller? So the rule that is in bold down here is that the cation with the highest positive charge has the smallest radius, while the anion with the highest negative charge has the largest radius. And so remembering that and remembering what our ion charges are, we can easily say that, oh, the smallest is going to be calcium. It has the highest positive charge, followed by potassium, and then sulfur with a -2, and then our largest ion, which has the most negative charge, is that phosphide ion, -3. So you should feel comfortable being able to determine if a series of species are in the same isoelectronic series, and if they are, be able to rank the sizes of those particular ions. And that, my friends, is the end of this chapter.